Assalamualaikum. Good evening, everyone. We want to continue on this problem, and the problem we have done part of the problem. We have calculated the equivalent resistance of this DC circuit, and we have replaced all the resistors here into one equivalent resistance so that we can calculate the value of I1. The current that leaves the battery is I1, and we have calculated that to be equal to 1.48 ampere. Now we want to find the rest of the currents that flow through the 5 ohm resistor I2, the current that flow through the 7 ohm resistor I3, and the current that flow through the 9 and 1 ohm resistors I4. So how to do that? We have to apply the Kirchoff's law. Kirchoff's laws, there are two: the junction rule and the loop rule. Okay, first we can establish an equation based on the junction rule, and you can see there are many junctions. Then you can see 1, 2, 3, 4, but then these two junctions actually is one junction here, because there is nothing in between. So you can establish an equation describing the flow of current. Current going into this junction, you can regard this as one junction. Okay, the current that goes into this junction is I1, and the currents that comes out of it are I2, I3, and I4. And so we apply the junction rule of Kirchoff's laws. So it will be I1 equal to I2 plus I3 plus I4. On the left hand side is the current that is going into the junction. On the right hand side are the currents that going out of the junction. Okay, so that is one equation. We already know what is the value of I1, so later on we can replace that. Okay, now there are three equations that we need to develop based on the three loops that we have. We have three loops. This is loop number 1, loop 1. This is loop 2. We draw an arrow going clockwise. Okay, for all the loops here. This is loop 3. So for the first loop, the loop rule says that the sum of all the voltages that goes around this loop equals 0. So there will be voltage rise when it passes through the battery, and then there will be voltage drops passing through the 3 ohm resistor, 5 ohm resistor, and 2 ohm resistors. And the voltage drop is voltage is equal to, we apply the Ohm's law, V equal to IR. And so we can establish the equation for loop 1. It should start with the battery, 12 volt, and then as it passes through the resistor. Okay, now we have the resistors, the 3 ohm resistor. Current is going from left to right, so the polarity of that resistor is going to be plus and minus there. And we have I2, the current going into the 5 ohm resistor, going to the from top to bottom, and so the polarity will be plus minus. And for the 2 ohm resistor, it will be the current I1 will be flowing in that direction, and so the polarity is plus over here and minus over there. So as it for the battery, it will be plus minus. It is the reverse. So as the voltage across the battery, as we go in the flow direction of the current, it is rising. But when it goes through the resistor, the voltage drop. Same for all three resistors. And so we have the equation starts with the battery, positive 12 minus 3, that is the resistance 3I1, minus 5I2. because the current that passed through here is I2, and then the current that passed through the 2 ohm resistor is also I1, minus 2I1 equal to 0. And we can simplify this because we have two terms involving I1, so 12 minus 3 minus 2, so it's minus 5I1 minus 5I2 equal to 0. And then we can solve this equation here because we already know what is I1, so we can replace 12 minus 5 1.48 minus 5 I2 equal to 0. We can find what is I2. So it should be plus 12 is equal to 4.6 divided by 5. You will get I2 equal to 0.92 ampere. Okay, that is when we establish the equation in loop 1. So we already know what is I1 and I2. Now we go for I3. We go to the second loop. So for the second loop, we have as we go by the direction of the loop 2 and we go across the 5 ohm resistor, we would be going from minus to the plus polarity. So in the equation for loop 2, we should start with 5I2, positive 5I2. And then there is another resistor here, 7I3. That will be minus because as the I3 is going that way, so it will be plus minus there. And this one, the current will flow that way, so it's plus minus. And so we have 5I2 minus 7I3 minus 4I3 plus I4. Because that is the current that flow in the 4 ohm resistor is going to be a combination of that current I3 and I4 that flows here into this junction here. Okay, equal to 0. And so we can simplify that because we have two terms involving I3. So 5I2 minus 11 I3 and minus 4I4 equal to 0. And we already know what is I2, so we can replace that. So what we have is we bring this to other side and we switch sides, so it will be we can have 11I3 plus 4I4 equal to, it will be positive 5 times I2. I2 is 0.92, so times 5 it will be 4.6. Okay, so we have an equation established by the loop rule for the second loop. And now we go to the third loop, loop number 3. There are only there are 3 resistors, so it's going to be as we go in the direction of this arrow here, this term will be, the voltage across this will be positive because it goes from minus to plus as it goes clockwise. So it will be 7I3 minus, this one is going to be plus minus because the current will flow that way, minus 9I4 minus 1I4, so just I4 equal to 0. So 7I3 equal to 10I4. So you can replace this one. I3 will be I3 will be equal to 10 over 7 I4 equal to 1.429 I4. So we can replace I3 in here. Which equation is that? This one. We can replace I2. So, we should be using this equation here. This is the final version of the equation from loop 2. So this, 11 I3, we replace I3 with this 1.429 I4 plus 4 I4 equal to 4.6, and then you can calculate this. It will be equal to times 11 equal to 15.71 plus 4. It will be 19.714. 19.714. So I4 will be 19.714. Up here is 4.6. It will be equal to 0.23 ampere. That is the value of current I4, and for I3 just use this one. So I3 is going to be equal to 1.429 times 0.23. It will be equal to 0.33 ampere. And so you can summarize the current I1 equal to 1.48 ampere, I2 equal to 0.92 ampere, I3 0.33 ampere, and I4 equal to 0.23 ampere. So that completes part B of the question. You have done the analysis where you calculate the values of the current I1, I2, I3, and I4. Okay, thank you.